Hello and welcome to the second or next method of unsupervised learning. So we are going to see one more clustering method here called as hierarchical clustering. So similar to the k-means clustering, the output of hierarchical clustering is also same. We are going to create a group of the data within it, but the method and mechanism which is used by hierarchical clustering is something different. We use this particular method. Hierarchical clustering shows the data in the form of the trees, which is shown over here on the plot. That's what the main difference is, and few more changes also we can have in the output, and decision of value of clusters will also be decided. So let's see. So we have seen unsupervised learning flow. We are going to find the patterns in this particular data, and we'll create a group based on this database here. Now, how hierarchical clustering works? Hierarchical clustering is also known as hierarchical cluster analysis, an algorithm that groups similar objects into groups called as cluster. The endpoint is a set of clusters where each cluster is distinct from each other cluster, and objects within each clusters are broadly similar to each other cluster. So hierarchical clustering starts by treating each observation as a separate cluster. Then it repeatedly executes the following two steps, like identify the two clusters which are closest together, and second, merge the two most similar clusters together. It continues this until all the clusters are merged together. Okay, so let's start how it does these operations. At the start, treat each data point as one cluster. Therefore, the number of clusters at the start will be k, where k is integer representing the number of data points. So every point is considered as cluster. After that, it will form a cluster by joining the two closest data points. Okay, so two closest data points will be joined, resulting in k minus 1 clusters. Then form one more cluster by joining two closest cluster, resulting k minus 2 clusters. So go on, perform these operations, repeat these three steps until one big cluster is formed. Once cluster is formed, dendrograms are used to divide into multiple clusters depending upon the problem. So there is a tree data structure created, it's called as dendrogram. So with the help of the dendrogram, we are going to form visualize this particular data, and dendrogram will show you where exactly the clustering is possible. So now let's see how it works. So let's take this data present over here, identify the two clusters which are closest together. So see, these are the clusters I have formed, and out of all, which are the two closest clusters present. So for example, these two are closest, so they are combined together and a cluster or a group is formed. Okay, now after that, which two closest are there? This and this, these two. So they are connected together and we form it, or we may have these two clusters also combined together. So these two are same, so we are combined them together. Again, here from 6 we go to 5, again 4, and for example, if you go here, so this kind of 4 or this kind of 4, everything may be possible. Now after that, these are similar, so again they are combined together. So 1, 2, 3 clusters are formed. Next, now they are almost similar, so combine them together. So 1 and 2 clusters are formed, and now finally only they are similar, so finally a large cluster has formed. So this technique we called as agglomerative clustering, making the group of clusters which are similar to each other, and based on that we are going to create these groups, and this particular representation is shown in the form of a dendrogram. Check it out. So the main output of hierarchical clustering is a dendrogram which show the hierarchical relationship between the clusters. How it's done? So these are the plots. Now which are two connected first? So for example, check out, E and F are connected first, then A and B are connected, then D is connected to EF, then C is connected to DEF, and then AB are connected to CDEF finally here. So first relation, then second, then third, then fourth, and then fifth. So that dendrogram will show you the data in this particular format. And after dendrogram is formed, we are going to specify how many clusters you want, and based on that, clusters will be separated. Now we have taken one point consideration into a cluster. Okay, one point is considered under a particular cluster. So how it is identified? So there is a similarity measure used over here. The distance between the two clusters has been computed based on the length of the straight line drawn from one cluster to other. This is commonly referred as the Euclidean distance. We already seen this. We have seen Euclidean distance in k nearest neighbor. We have seen that in k-means also, and hierarchical clustering also we are going to make use of direct distance formula and take a new point within another cluster there. Okay, so many distance metrics are also developed. Let's see. linkage criteria. So these are the properties that are required to have a perfect hierarchical clustering mechanism. After selecting the distance metric, it is necessary to determine from where distance is computed. Because if single cluster is there, it's okay. But if I want to find the distance from a group of elements in a cluster, then from where you have to calculate the distance. So for example, it can be computed using the two most similar parts of the clusters called as single linkage. Then two least similar bits of the cluster is called as complete linkage, and center of the cluster is called as mean or average linkage, or some other criteria. Some other criteria means I can have distance matrix method, I can have wards method present over there. So these are the linkage criteria which decides the computational mechanism is from where you have to calculate the distance, and based on that we are going to create the dendrograms. Okay, so this linkage criteria also we need to specify while creating the agglomerative clustering here. So this clustering we called as agglomerative. Hierarchical clustering typically works by sequentially merging the similar clusters. This is known as agglomerative clustering. In theory, it can also be done by initially grouping all the observations into one cluster and then successively splitting these clusters. This is known as divisive hierarchical clustering. Divisive clustering is rarely done in practice, remember. Now check it out, how agglomerative clustering works and how divisive clustering works. So agglomerative works by combining, divisive will work by separating. Okay, this is how we can do it. Okay, so this is how clustering technique works. So before actually starting our practical, we require to have these packages. So pandas, numpy, matplotlib, scipy and sklearn. So remember, we haven't used scipy yet, but scipy is also installed along with the scikit-learn. Okay, so from scipy we are going to make use of linkage criteria function, and the dendrogram plotting is also done with the help of the scipy. So before actually working on the data set, I will show a small example of dendrogram here by which we can make use of implementation of it, because when you actually go for our data set, dendrogram will be a very big, and that will be difficult for us to identify the dendrogram. That's why I'll be making use of a separate mechanism here by which the dendrogram can be easily seen. So let's see, I'm importing a numpy, then a sample database I am creating here, a two-dimensional array where 10 entries are present, like 5, 3, 10, 15, 15, 12, 24, 10, like, and after that I'll be showing the particular plot of this particular data here. So let's create this data, and I want to visualize this data. So let's import the plot, and now I'm going to show the dendrogram from this particular data. So before showing the dendrogram, let's insert, or let's make use of one plot here. Let's use scatter. Okay, so let's use x of what you require was column number 0 and x of column number 1. Okay, so this is your plot. Fine. Scatter, we have plotted this data x and y. So x side these elements and y side these elements. So this is what plots we have done. You can easily see two clusters are possible here, one here and one here, but I have created this example to show you the demonstration of the dendrograms. So the dendrogram can be easily demonstrated with the help of this example. Let's see how dendrogram can be drawn. So let's see this. So this is how plotted the data. Now from scipy cluster package, hierarchy package, I am importing the dendrogram function and linkage functions. Dendrogram function is to draw the dendrogram, and linkage function is to decide which linkage criteria I am applying, which I have shown on the slide. So same linkage criteria we will be using over here also. Okay, so let's see how to use that. Okay, so let's import, and here I am creating a linkage criteria. So x is my input variable, and what's the linkage criteria we are using? Single linkage. Okay, that's what we are choosing over here. So linkage created, linked object is created, and we have labels from 1 to 10. So their list I have formed from 1 to 10. Okay, so because 10 elements are present here, so I want that number should be present in front of the nodes of the dendrogram. Now let's the last one. Figure size I am keeping 10 by 7 resolution, and now here the dendrogram. Dendrogram I am going to draw it by which linkage criteria? This one. On this data I am applying this linkage criteria. So that's I am applying over here. Then orientation is equal to top, top orientation. Now what labels I want to give, that is label sort, label list, and which sort I am using, descending sort. This is not required. And do you want to show the leaf counts? Yes, true. So these parameters are mentioned to the dendrogram, and for the given data for 10 elements, how dendrogram is formed. So by dendrogram we can see that this dendrogram is formed by similarity notions. How similarity notions are there? Yes, see, you can check it out. Now first 2 and 3 are the nearest point, they are connected. Then 4 is connected to 2 and 3, then 7 and 8 are connected, then 1 is connected to 4, 3, 2, then 10 is connected to 7, 8, then 6 is connected to 10, 7, 8, then almost at same position these two are connected, and finally these are connected over here. Fine. So in this way this dendrogram is drawn. You can see on the leaf nodes, on their nodes we can have the labels list mentioned here. This is a label list, and how dendrogram looks like for data. So I am having only 10 elements present over here in this array, and for 10 elements this dendrogram is seen. So this is why your single plot, scatter plot, and the dendrogram will be something like this. Now the original data set on which we are working, we are having 200 entries in it. So if you plot the dendrogram, it will be very difficult to visualize that, or we have to reading is also very difficult for 200 entries. That's why I have taken this example to visualize you how the dendrogram actually looks like when you create it for a particular data set here. Okay, let's go for our actual applications. So this is how dendrogram looks like. Linkage function, I'll be using data y here, and method is single. Default method is single. We can make use of words method, complete linkage also, average linkage also, and metric is Euclidean distance formula. Okay, dendrogram function. If you plot the hierarchical clustering as dendrogram, it's used to do that one. The dendrogram illustrates how each cluster is composed by drawing a U-shaped link between the non-singleton cluster and its children. The top of U-link indicates the cluster merge. The two legs of U-link indicate which clusters are merged, and the length of the two legs of U-link represent the distance between the child clusters. It's also the cooperative distance between original observation in the two children clusters are. So this is what the output that I am generating out of this. So you can see easily how the clusters are connected together and how dendrogram is formed. So how to check that? For example, I want to create 4 clusters. I'll have a cut over here. 4 clusters. So this will go in one, and this will go in another cluster. And I want 4, so I'll have a cut over here. So 1, this is 2, this is 3, and this is 4. Okay. So in this way, if you go somewhat below, then 5, 6, 7, 8, 9 clusters will be created. So checking how many clusters are possible, we can have this horizontal line, and we can identify which point will go in which particular clusters and what will be the count of it. Okay, that's what we are going to see. Now come to the actual point. This data set we have already used in the KMS clustering. Okay, so let's assume this data set of customers. This information of clients that subscribe to membership card maintains the purchase history score, and the score is dependent on the income and the number of times in a week they show up in the mall, total expenses in the same mall. So from this data set, in last algorithm also I have identified 2 most important parameters. The parameters are annual income and the spending score. So based on annual income and spending score, I'll be plotting the dendrogram, as well as I'll be doing the clustering, the agglomerative clustering that we have seen in the previous diagram. By combining them together, and then we'll be having a split. With the help of the split, the groups are formed. Okay, and that further remaining operation will do onto it. So let's go for actual implementation of the data here. So yeah, so same data set, import pandas, read the CSV file, and last 2 columns I will be showing annual income and spending score, 3 and 4. I am storing inside the variable x. That data frame contains spending score and the annual income and the spending score inside. Now let's follow the dendrogram first. Okay, so let's see this from SciPy cluster hierarchy, import dendrogram and linkage criteria, import the matplotlib, and now let's create a dendrogram. So here I'm keeping figure sizes 16 by 9. Title I'm giving customer dendrogram, and dendrogram I'm forming by linkage, and on this data x data which I extracted, and the method for linkage I am using is words method. Okay, so check this out. The dendrogram is getting formed. Yes, see, it's very complicated actually. 200 entries are there in the given data set. Okay, so all these 200 entries you can see here. Check it out. So how many clusters are possible? If you have a cut over here, we'll have 5 clusters created. If you have a cut over here, you can have 3 clusters created. Fine. Or you can have a cut over here. So 1, 2, 3, 4, 5, 6, 7, 8 clusters are possible. Okay, so in this way, how these similar points are connected together by which mechanism is shown by this particular dendrogram here. So very complicated to see it. The numbers are shown over here for the particular point, but it's not visible because it's very compact. Done. Now, how to apply the clustering techniques? So clustering algorithm is called as agglomerative clustering. Here in sklearn.cluster we have this algorithm whose name is agglomerative clustering. So agglomerative clustering will perform the clustering and will assign the labels to respective points there. So how to do this one? So let's go for that. Okay, so let's import the clustering first. Now CLS is equal to agglomerative clustering. How many clusters you want? So I have given 5. That's very interesting. I have given 5 here because I know that 5 is the ideal value for this particular clusters. So I am using elbow method already. By elbow method I have shown that 5 is the ideal value, so I can have other ideal values also. But if you see the difference here it is showing 3. So this is green, red and the cyan. See, 3 difference are shown here. The 3 is shown by it, but I know that 5 ideal values present. Linkage is what, and affinity means the finding the distance. I am using Euclidean distance formula there. So these parameters I am passing. Let's go. It's created. Now further operations are same. Here we don't have the centroids, or we don't have the inertia also, because these are the properties of the KMS clustering algorithm here. So I have created the object CLS, and now on that object we are going to do fit underscore predict x. Okay, so apply this x data here, fit predict. It will apply the agglomerative clustering and will create the labels here. So labels will have the labels of this cluster. Check it out. 0, 1, 2, 3 and 4. So 5 different groups are formed and the labels are assigned to them by agglomerative clustering mechanism. Check this all. Done. So this is how we are going to do the clustering, and now let's visualize it. So to visualize that, I'm using 16 by 9. On X side I will be using annual income, on Y side I'll be using spending score, and now let's plot it. So here I assign the labels directly. In the previous example we haven't used any labels. Previously I have shown first unclustered data. Let's see unclustered data also. Okay, so scatter x.iloc 0th column on X side and x.iloc column number 1 on Y side. Color map I'm using rainbow. So this is not required, but okay, it's fine. Check. These are the original points present here, and what labels you generated, labels, this will assign, I will assign to the colors in the cluster. So C is equal to labels. Now see, perfect. Cluster number 1, 2, 3, 4 and 5. So 5 clusters I formed after this. So as per the labels, the colors are assigned, and colors are showing you how this looks like. Check this. If you have seen the previous example of k-means, you can observe the difference. Is there any difference? Actually no difference. If you thoroughly see this one, colors are different only, but grouping is almost same. But see, you will have a difference there also. This data also you can extract in the same way that we have seen in the last slide, last video. By using Boolean filtering, we can extract that information and we can save that information in another file also. But see, what's the difference? Is there any difference there? I'll go to my original file of clustering, which k-means. Okay, check it. Let's go for the original file here. Okay, I'll show the last plot and let's compare these two plots. See, this plot and this plot, they are almost same, but see, higher clustering will do almost in similar way, but we will have the problem in the boundary points. Let's consider boundary points. See, these 2 points present over here. Okay, these 2 points, both of these points are in the middle cluster, correct? Now here you can see this one. this point is in middle cluster and this point is in above cluster, correct? Is that in k-means? Okay, and let's go for these points. So you can observe in this particular area total 6 points are present, correct? 6 points. Out of 6 points, these 3 points are in middle cluster and these 3 points are in the below cluster, correct? These are 3 yellow and these 3 are purple, correct? They are yellow and these are purple. Out of these 6, let's go for hierarchical. Check this, all of these points are in the middle cluster, correct? So that's the difference. We may have the problem on the boundary points because every cluster's mechanism, every cluster's algorithm is different and it perform operations as per their algorithm. So clustering can be done almost correctly. Everyone will look from different point of view, but it may create the problem for the boundary points only. The boundary point may be changed from one cluster to another cluster, so it may go to the neighboring cluster also, or it may go to the previous clusters also. So that's what the difference are there that these clustering mechanisms are currently having. So this is how clustering can be done. We can save this data, even we can predict also. So let's have that saving the data file over here. So just I'll add one row here. Okay, let's save this. So for example, I want to save cluster number 5. So data of, so data, is it the data that we have read? Correct. So data is there, data of labels is equal to 4.2 underscore CSV. So let's save this file in the 4.csv. So it's saved. Check it out. Is it present here? Let's go for 4. Where is the 4? Yeah, this one. Okay, this is cluster number 4. Okay, so total 23 elements are present in it, cluster number 4, and they are separated. So this is how we can separate the data points from the particular clusters based on the labels assigned over there. And now I want to do the prediction for a new data points. For example, a new customer is coming whose spending score is 45 and annual income is 89, correct? And let's do cls dot predict. Okay, let's put predict is required, predict cust and 0. Okay, what's the problem again? No attribute predict. Okay, sorry, this is predictions are directly not possible on the agglomerative clustering. Okay, this prediction which I have done over here, let's try the different methods which we can see. So prediction function is not available here for this particular algorithm here. So it's available only for the k-means clustering where we can do the predictions. Here we need to add that entry inside the point itself. Okay, so that's how we are going to make use of the hierarchical clustering. Now let's check a few more clustering methods. I'll not go in detail for the algorithms, but there is very commonly used method called as the Gaussian mixture clustering. So Gaussian mixture clustering is one of the method which by which we can do clustering almost in similar way. Let's see that I'm importing it. I'll not show for detail, but I just want to change the prime algorithm there. So let's see, from skleon.mixture I'm importing Gaussian mixture, and in Gaussian mixture n components means how many clusters you want, that you have to specify here. N component equal to 5. CLS is created and then cls.fit predict and print the labels. See, this is what the labels I got, 0 1 2 3 4. Okay, and let's check the graph for Gaussian mixture. See, okay, yeah, this is Gaussian mixture clustering. Again you can see these points. Yeah, this is very interesting to see. Now in case of hierarchical clustering, all are in middle cluster, and Gaussian mixture is showing this point in this cluster and remaining 5 are in above. K-means was having 50-50. Okay, all of them are in this cluster for hierarchical, and Gaussian mixture which I am using here, 5 are in middle and 1 is going over here. So every clustering method mechanism uses different approach, different algorithm to create the clustering, but the groups are possible. It may create the point problem on the boundary points. So it depends if you want to use which particular method. Depending upon the speed you can choose it. Clustering can be formed easily, so decision making on the clustering will be beneficial for us in future also. So this is how we apply different clustering mechanisms here, by which we have performed the grouping of the data, finding the pattern, and based on similarity notions or using different mechanisms, we have formed the grouping of this particular data. So you just try this algorithm on different kind of data sets, whether the clustering works fine or not. Okay, that's from my side. Thank you. Thanks a lot.